Oakley dokley. Let's do our very first Kirchoff practice, number 1. So first things first, what are our Kirchoff rules? So if you didn't look at the video I posted already, our Kirchoff rules are the Junction Rule and the Loop Rule. So the Junction Rule basically just says, if I have a junction, the current that goes in is equal to the current that comes out. Or in picture form, boop, 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 boop. If this is I1, this is I2, and this is I3, in this junction, I1 is going in, and I2 and I3 are coming out. So that's how you would write down a junction rule. For a loop rule, if we have a loop, the sum of the voltages from point A to point B, or in a closed loop, excuse me, so from point A back to point A is equal to 0. So if we assume that our current goes this way, and I follow that current, so I go through this loop, I get plus my EMF, come down, and I lose current times voltage, or current times resistance, and that's equal to 0. So loop rule is what usually trips people up. So we're going to do some examples. So the first thing you want to do is to draw currents going through the thing. So I like to start at the battery. So I'm going to assume that current number 1 comes out of my battery and goes this way. Now what direction you draw your currents doesn't actually matter. You can draw them whatever way you want, and analyzing your circuit with these rules is going to tell you whether that direction is right or wrong. So this current is number 1, so I'm going to extend this all the way down into that junction. So this entire blob of wire has the same current. Then through this branch, I'm going to assume it goes this way. I'm going to call that current number 2. And for this branch, that's going to be current number 3. Okay? So first thing you do is you draw in your currents. The actual direction doesn't matter. You just want one current per branch, labeled accordingly. Okay. So now let's look at our junction rules. So we have 2 junctions here. We have a junction here, and we have a junction here. So at this junction here, I have I1 going in, and coming out I have I2 and my pink I3. Down here, going in, I have I3 and I2, and I have I1 coming out. So you notice that these are the exact same equation, just rearranged. It's because we have only one branch. So the junction here is going to be the same as the junction here. That's not always going to be the case. Alright, so the next thing we want to do are our loops. So we have 3 loops that we can look at here, which I'm going to draw in orange. So I have the loop around here. I have the loop around here. And I have a loop around the entire thing. Okay? So let's do loop number 1 first. So loop number 1. Alright. So loop number 1, I'm going to start over here. Again, it doesn't matter what direction you actually go in. So I'm going to follow my loop. So if as I'm following my loop, my current is going through the battery from minus to plus, swoop, swoop, I'm going to add that battery. So I have plus 5 volts. Now I keep going, and I hit this resistor. So now if my current is going through my resistor the same direction I'm traveling, then that's going to be minus IR. So minus I1 times 2 ohms. Now for this loop, I'm coming down this middle branch here. Now I'm going with the current through this 4 ohm resistor. So that's minus I2 times 4 ohms. Shoot, boop, 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 and I'm back where I started. So my entire loop needs to add up to 0. So with loop number 2, now I'm going to start down here. So I'm going to travel this way, the way that I've drawn my loop. So now I'm going against the current through this resistor. So my current's going down, but my loop is going up. So I'm going against the current. So that's going to be plus I2 times 4 ohms. Now I'm going against the battery. So it's going to be minus 3 volts because I'm dropping from plus to minus. When I come this way, I'm going with the current now, because my pink current's going this way. So it's going to be minus I3 times 6 ohms. And now I'm back to where I started. So now if we look at loop number 3, I'm going to start here at this green spot. And I'm going to go this way. So now I'm going minus to plus, so I'm getting boosted by this battery. So that's plus 5 volts. I'm going with the current, so that's minus I1 times 2 ohms. Now I'm going against this battery, so I'm losing voltage. So minus 3 volts. Now I'm going with this current, so minus I3 6 ohms, and I'm back to where I started, equals 0. Okay, so to summarize, so if I'm following my loop, sorry, ran out of space. Okay, so in general, if our loop is going this way, if we are going with the current through a resistor, that is a current drop. So that's going to be minus IR. If our loop is going this way and we're going against the current, that's going to be plus IR. And for our batteries, if we're going from minus to plus, that is a voltage boost. So that's going to be plus V. And if we're going from plus to minus, that is a voltage drop. So that's going to be minus V. Okay, so now we have a bunch of equations, and a couple unknowns. So here our unknowns are I1, I2, and I3. And we have 4 equations to help us solve that. So we're pretty good. We're all set. We're going to be just fine. So we look at our loops. I'm going to come over to a new piece of paper. Blah, 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 blah. Okay, so now we have 5 equations, even though this is technically the same equation. So 4 equations, and we have 3 unknowns, I1, I2, and I3. So we know right away that I1 is equal to I2 plus I3. So I'm going to stuff that in here. So my equation number 1 becomes 5 volts minus I1, which is I2 plus I3 times 2 ohms minus I2 times 4 ohms is equal to 0. So I can simplify this out. 5 volts minus I2 times 2 ohms minus I3 times 2 ohms minus I2 times 4 ohms. I can combine my I2s, so minus 2 I2 minus 4 I2, so that's 5 volts minus I2 times 6 ohms minus I3 times 2 ohms is equal to 0. So now I'm going to solve for I2 or I3, either one. And then I'm going to end up stuffing that into equation 2, because that's going to let me solve for just one. So I'm going to do I3 just because it's already right there. So I have 5 volts minus I2 times 6 ohms is equal to I3, and then divide over here by 2 ohms. So now I'm going to take this and I'm going to shove it into equation number 2. So equation number 2. So now I have I2 times 4 ohms minus 3 volts minus I3, which is growth, 5 volts minus I2 times 6 ohms over 2 ohms times 6 ohms is equal to 0. But now everything is in terms of I2, so I can solve this one for I2. So I'm going to pull these all apart, and I've got I2 times 4 ohms minus 3 volts minus 5 volts over 2 ohms times 6 ohms minus a minus, so that's plus an I2 over 2 ohms times 6 ohms times 6 ohms is equal to 0. Alright, so now I have I2, I've got 4 ohms, and then that's volts, I got an I2, I have a 36 over 2, so that's 18. Then I have minus 3 volts minus 5 times 6 is 30 over 2 is 15. So now I have I2, 4 plus 18 is 22. Minus 3 minus 5 is minus 18. So I2 is 18 volts over 22 ohms, or 9/11 amps. Okay? So the algebra is like super duper tedious on all these, but like once you get the equations, then it's not awful. So I'm going to take I2, I'm going to stuff it back in here to get I3. So I3 equals 5 volts minus I2, which was 9/11, times 6 ohms all over 2 ohms. So I'm just going to stuff that into a calculator because I don't want to do that with fractions. So I have 5 minus 9 over 11 times 6 divided by 2. So that's 0.045 amps. And then from here, I1 is I2 plus I3. So that's going to be my 0.45 plus 9. That is not what I typed. Damn it. 0.045. Clear. 0.045 plus 9 over 11. 0.86. 0.86 amps. Okay, so now all of my currents came out to be positive numbers, which means the currents that I assumed the direction they were going is the direction it's actually going. So if any of these had come out as negative numbers, that just means that the direction I drew them here, in reality, the current is going the opposite way. And that's it.